The Pennsylvania Department of Transportation is charged with the responsibility of maintaining 44,000 miles of highway and 25,000 bridges. Most of the time, this means that we are busy doing roadway and bridge repair. But when the mercury begins to drop, our top priority changes. Our attention turns to snow and ice and the problems they cause drivers. It is our mission during the winter months to keep all the state roads open and in a reasonably safe and passable condition. This program discusses the levels of service you are expected to provide, as well as the plowing and spreading procedures associated with snow and ice control. The program agrees with Chapter 4 of the Maintenance Manual. Both the manual and this presentation discuss general guidelines for winter maintenance operations. But due to the varying conditions associated with snow and ice control, it is simply not possible to discuss every situation that may arise. If you run into a problem not addressed in the manual or presentation, it should be discussed with your supervisor. In order to provide the most efficient and effective winter maintenance operations possible, it is necessary to set priorities by Maintenance Functional Codes, or MFC. All state highways, therefore, have been classified into 3 basic categories: first, second, and third priority highways. First priority roads include all interstate and limited access highways and are referred to as MFC A and B. Second priority highways, MFC C, are usually major local roads having high traffic volumes and are important commercial routes. The third priority roads are secondary and rural roads with light traffic volumes and are designated as MFC D and E. What is the proper level of service for each type of roadway? It varies. Top priority highways receive a very high level of service. Lower priority roads are serviced to a lesser degree. Let's take a closer look at exactly what you should do when treating or plowing roads in your county. We will begin with the top priority highway. The number 1 priority when planning snow and ice control services is the interstate system. All interstate highways are to receive top preference when assigning equipment. Interstate service frequency during a snowstorm should be about 2 hours. The higher speed limits, vehicular and truck traffic volumes, and the emergency planning that centers around these highways requires that all traffic lanes be open and passable at all times. This is what happens when an interstate highway is closed during a snowstorm. This is how interstate highways should be maintained during winter storms. Other limited access highways are also first priority. Their service is rated slightly behind the interstate system. Depending on local conditions, some snow may be permitted to accumulate, and the 2-hour service frequency may not be required during non-peak traffic hours. This is acceptable service for a limited access, non-interstate highway during peak traffic hours. When servicing any limited access highway, special attention must be given to interchanges, including entrance and exit lanes. Vehicles must be able to enter and leave the main highway. One stuck vehicle on an interchange exit lane can result in a traffic tie-up that can close the highway and cost hours of work. Some interchanges are easily serviced with little disruption to mainline operations. Complex interchanges require planning to service properly. It may be necessary to assign a separate truck to work primarily on interchanges. At the discretion of the district engineer, certain important non-limited access highways may be designated as first priority. The level of service to these highways may be the same as that assigned to non-interstate first priority highways, although equipment assigned to the interstate system should not be decreased to favor a local highway. Counties having no interstate or other limited access highways may select key second priority highways to receive first priority service. Route 6, which runs continuously through 6 northern tier counties, is offered as an example. Second priority highways often have lower speed limits and traffic volumes that drop noticeably in the late evening and early morning hours. Adjust service to those conditions. Major efforts should be directed toward the 6 a.m. to 8 a.m. heavy traffic period. The level of service may drop slightly during the day, but should increase from 4 p.m. to 6 p.m. During the non-peak traffic hours, up to 4 inches of snow can accumulate. This is proper service for a second priority highway during the morning rush hours. Concentrate on lanes heading to work areas and population centers from 6 a.m. to 8 a.m. Do the opposite from 4 p.m. to 6 p.m. Third priority roads, maintenance functional classifications MFC D and E, carry moderate to minimal traffic, and speed limits are usually 35 miles per hour or less. Material applications should be concentrated at critical locations: bridge decks, sharp curves, steep hills, and intersections. Almost every third priority road is a school bus route. Do your best to make sure these critical locations are serviced before school buses take to the road. It is not necessary to provide this type of high-level maintenance to third priority roads. This type of treatment, applying de-icing materials the entire length of third priority roads, is a waste of money that could be put to better use repairing and maintaining highways. Snow accumulation of up to 5 inches can be permitted on third priority roads during general storms. It is not necessary to spread de-icing materials on the tangent sections of third priority roads or to plow to bare pavement. Note that the vehicles have no problem traveling on the snowpack. During severe extended general storms, third priority roads will occasionally close. Normally, a road should not be closed for more than a few hours. Anytime a road is closed for over 24 hours, the situation is considered critical and emergency planning will go into effect. Another aspect of service that must be considered is widening and cleanup operations. Normally, overtime and rented equipment should not be used for widening operations. Within these guidelines, widening and cleanup operations are to be started and completed as soon as all travel, passing and turning lanes are cleared of ice and snow. Widening and cleanup operations are to be accomplished by roadway priority. Interstate highways are considered as widened when all snow has been plowed from the shoulder areas and all interchange areas, including ramps, have been widened and gore areas have been daylighted. Other roads are to be widened in accordance with their physical properties, so as to allow vehicles to stop for emergencies and facilitate snow storage. Snow that blocks visibility at intersections should be removed. When clearing bridges, don't throw snow over the bridge onto roadways, railroads, or any other place that could result in damage. At railroad crossings, it is important that snow be removed from the rail flange area and not piled against signals, switch boxes, or signs. Care is to be taken to make sure that snow is pushed back sufficiently from the high side of superelevated curves to prevent snow melt from running onto the pavement and freezing when temperatures drop. Inlets and drainage courses must be kept open. Flooding occurs even in the winter and can turn to packed ice if the temperature drops. Once thick packed ice forms on the roadway, it presents a serious safety problem and is very difficult to remove. Planning a widening operation must be tempered with good judgment. It is very important that highways in a heavy snowfall county such as Erie have a complete widening. Widening for snowstorms occurring in more southerly counties, such as Dauphin County, would not be considered so critical an operation. Here, the temperature is above freezing and the snow is melting. This widening operation is of questionable value. Here, there is so little snow on the shoulder that the plow is creating a dust storm, another widening operation that is of questionable value. In this scene, a windrow from widening the interstate shoulder was thrown onto the entrance ramp terminal, creating a very dangerous situation. Use your second and third shifts when possible for widening operations. This concludes the first part of our program. We have looked at the various levels of service expected for the different types of highways. Part 2 of the program will look at operational procedures used to provide those levels. Part 1 of the Winter Season Operations Program explained highway maintenance priorities and the expected levels of service. In this portion, we will discuss operational procedures to provide that service. Winter maintenance is a year-round job. Planning and preparation during the spring, summer, and fall is the most important part of it. If planning is not done properly, materials stocked, and equipment ready to go before the first snowfall, it will be impossible to do the job efficiently, no matter how good or experienced the maintenance organization has become. During the spring months, the past winter's operations must be reviewed, and both good and bad points noted to help in planning future operations. Equipment must be inspected and parts inventoried and ordered. Salt and anti-skid materials must be inventoried. Stocking areas cleaned and anti-skids swept from the highways. This is a good time to plan major improvements, such as dome salt storage buildings. A properly developed stocking area, such as shown here, facilitates both winter and summer operations, eliminates environmental problems, and improves the department's public image. In the summer, snow maps must be prepared, rental and municipal equipment agreements executed, shifts for the coming winter planned, and equipment refurbished. Fall preparation includes stocking de-icing materials, equipment calibration, operator dry runs, and final winter meetings. When winter arrives, almost every storm at least starts as a spreading storm. Proper and timely material applications are important factors in fighting winter storms. The department primarily uses salt, abrasives, and combinations of these materials to control ice and snow. Salt, sodium chloride, is the chemical most widely used to clear the pavement completely during light snowstorms and to facilitate plowing when heavier snowstorms occur. Salt is most effective when we have temperatures of 25 degrees Fahrenheit or above, heavy traffic, and sunlight. When these ideal three conditions exist, minimal salt applications will react and turn the snow to slush within 15 or 20 minutes. When one or more of the three ideal conditions decrease, salt application may need to be increased and reaction time may take longer. The three conditions necessary for salt to work occur in different variables and combinations. Although judgment must be exercised, the maintenance manual will assist you to decide when to use salt or when to use abrasives. While it is not possible to show all the variables and combinations that make salt work or not work, there is one simple rule that is easy to follow. Anytime salt takes over 45 minutes to react, salt applications are not effective. Straight salt is approved for use on first and second priority highways. On occasion, Straight salt may be used on some third priority highways if temperature, traffic, and sunlight make salt applications effective and economical. Let's look at an example of an effective salt application. Time, late afternoon. Traffic, light. Road, MFC C. 2 lanes. Skies, cloudy. Temperature, 28 degrees Fahrenheit. Application rate, 300 pounds per 2-lane mile wind road. The initial salt application is spread. Note the narrow windrow application in the center of the traffic lanes. This is the proper application technique, as no part of the application is wasted. 15 minutes later, there is evidence of reaction. This is the roadway condition 30 minutes after the initial application. This is the roadway condition 45 minutes after the initial application. The combination of salting, traffic, and temperature has cleared the snow from the pavement. Abrasives are the other material used for ice and snow control. Abrasives are inert and cannot melt ice or snow. Abrasives do provide traction and are mainly used on third priority roads. Second priority roads are treated with abrasives during the late evening or early morning traffic hours, or during severe winter storms when salt takes over 45 minutes to react. Abrasives may be used on first priority highways if salt alone is not effective. It is common practice to use a mixture of salt and abrasives. Abrasives to salt mixtures of 1:1, 2:1, 3:1, and higher ratios are all used. No matter which material is spread, it must be kept on the traffic lanes to be effective. Spinners should be restricted to make sure that material is not spread next to or on the roadway shoulder. Here is the proper method of applying materials to the high side of a super-elevated curve. Spreading in this manner assures that all the material spread falls on the roadway. The material is then worked by traffic, providing traction, and in the case of chemicals, aiding reaction. De-icing materials, especially salt, should be spread as soon as the snow accumulation is sufficient to catch the material and keep it from bouncing to the roadside. Salt spread by windrowing at 300 to 500 pounds per 2-lane mile will melt only about 1 inch of precipitation. 1 inch of precipitation or less is considered a spreading storm. This shows the result of a proper salt application. Note that the traffic is moving with no problem. Plowing should begin when snow depth is between 1 and 2 inches. 2 inches of snow or more should never be burnt from the roadway by excessive salt applications. First priority limited access highways are worth some special consideration. Tandem or plow train operations is an effective tool to accomplish the goal of having all first priority travel lanes open and passable. This method of plowing consists of 3 trucks plowing from left to right to clear 2 vehicle paths or 24 feet of roadway. The slowest truck will be placed first and positioned on the left or median side of the highway. The first truck will plow toward the median. The second or middle truck will be placed behind the first truck and plow the center of the highway. This truck will plow snow toward the right or shoulder side of the highway. The last truck will be placed on the right-hand side of the highway and also plow toward the shoulder. The third truck is also responsible for spreading materials if a plow spread operation is underway, as material spread from this truck will not be plowed off the road. The most experienced operator should be in the third truck to watch over the operation, especially truck spacing. This truck should be radio equipped. It is recommended that the plow train prohibit passing while the plow train is in operation. If any vehicle challenges the plow train to pass, let the vehicle pass. Safety is your first concern. Remember, after an accident has happened, the fact that it was not your fault is of no value. This shot shows an interstate highway with the passing lane cleared and the driving lane covered with snowpack. This is considered unacceptable maintenance and would not have happened had a plow train been used. Sometimes, no matter how good a job we do, accidents still occur. The last items to be addressed in this presentation are common courtesy and common sense plowing and spreading. Extremely cold temperatures, high winds, and blowing snow sometimes make it impractical to do any type of maintenance. This shot shows a situation where the proper course of action is no action. At the beginning of many storms, and sometimes during other freezing conditions, certain locations will become immediately difficult for traffic to negotiate. These include bridge decks, steep grades, sharp, super-elevated curves, and major intersections. Snow patrols should check these areas if it appears likely that freezing may occur. Operating a truck during storm conditions is a demanding job that requires strict attention. A truck bed should never be fully raised when spreading material. The bottom of the bed should be no higher than the top of the cab. If your truck bed is fully raised, you risk the possibility of hitting bridges or overhead utility wires. A fully raised truck bed also changes the center of gravity of the truck and increases the chances of overturning when negotiating hills and sharp curves. When plowing in built-up areas, slow down. Stay as far away as practical from mailboxes and ornamental shrubbery. Department equipment windrowing snow in front of private driveways is a very common complaint from the public. While we can never eliminate this problem, it can be reduced by slowing down and slightly raising the plow blade in residential areas. Following the priorities and procedures outlined in this program and Chapter 4 of the Maintenance Manual will result in a well-planned and executed winter operation. Remember, the key ingredients are careful planning, quick response, and attention to detail. Thank you.